Today I want to discuss with you the relationship between the molarity and normality. Relationship between molarity and normality. So generally we know that molarity, what it explains, the number of moles of solute particles present in 1 liter of the solution. That means we can write molarity is equal to N by V in liter. Okay. Now N is the number of moles of the solute. It is moles of solute. So V is volume of solution in liter. So by using this formula we can write molarity capital M is equal to N by V. Now I am converting into milliliter. So N by V in milliliter. So we can multiply with here 1000. This is the one formula for molarity. Next, another one is normality. So in normality means the number of gram equivalents, GEN by volume in liter. So GEN represents number of gram equivalents. This one is number of gram equivalents. And what about this V here again? Volume of solution in liter. Again we can write by using this only normality capital N is equal to N by volume in milliliter into 1000. So this is the equation 2. So in these two conditions we can write molarity by normality is equal to, from equation 1 and 2, molarity by normality is equal to N by volume in milliliter, this one from molarity into 1000. By means, now I am writing here reverse. How to write that condition? Volume in milliliter by, here N means now I am taking it is like equivalence only, GEN. It is in small n means here number of moles. Now I am taking here GEN. So take this one also, GEN into 1000. So volume in milliliter, 1000 gets cancelled. So next we can write here molarity by normality, which is equal to N by GEN. So generally we know that here number of moles we can write weight by molecular weight of solute, and gram equivalents also we can write GEN is equal to number of gram equivalents is equal to weight by gram equivalent weight. This is gram molecular weight, this one is gram equivalent weight. So substitute in this M by N, molarity by normality, the ratio of M by N which is equal to weight by gram molecular weight into gram equivalent weight by weight. So again weight relation cancelled. Then we can write GEW by GMW. So M by N. So in this process M by N is equal to gram equivalent weight by gram molecular weight. So now afterwards we can write here, we know that gram equivalent weight is equal to, so generally that is gram molecular weight by N factor. This is the another formula. So if you substitute this formula in this, you will get M by N, which is equal to gram equivalent weight is nothing but we can write gram molecular weight by n factor into already the denominator has gram molecular weight. Both gets cancelled. So finally we can write molarity by normality is equal to 1 by n factor. So 1 by m by n is equal to 1 by n factor. So here we can write molarity is equal to normality by n factor. So we can use either this formula or normality is equal to molarity into n factor. So these are the two formulas. Okay, here just now we discussed that one, molarity by normality is equal to 1 by n factor. Next here, based on the normality, so what we can write here, normality is equal to number of gram equivalents by volume in milliliter, or we can write a normality is equal to number of gram equivalents by volume in liter. So by using this formula we can write number of gram equivalents is equal to normality into volume in liter. Okay, this is the one formula. So or if you want to write that one, number of gram equivalents which is equal to normality into volume in milliliter by 1000 also we can write. This is also another formula. By using these formulas, if you take any two acid or base conditions, we can apply these formulas also. So already I shared in shorts only few formulas, this related only. That one, NaVa is equal to NbVb. That meaning this is for acid, this one is for base only. For acid base reactions, we can write the neutralization process is NaVa equal to NbVb. Or we can write another formula also. Sometimes they will give NaVa is equal to this NbVb is nothing but number of gram equivalents also. No, we can write gram equivalents of base. This is for acid. Or we can write this one, NaVa is equal to number of gram equivalents of base only, which is equal to weight by gram equivalent weight of base also. We can relate with weight by gram equivalent weight relation. Sometimes they will give these relations, N into V in milliliter given means take by 1000 for acid, which is equal to weight by gram equivalent weight of base. So this is also another formula. So by using these formulas, so how to solve that questions now we will discuss. Okay. Here, so come to this one problem. The volume of 0.025 molar calcium hydroxide solution which can utilize 100 ml of 10 power of minus 4 molar H3PO4 is. So he is asking the volume of the calcium hydroxide only, concentration alone given. So according to that, first, so volume we have to calculate for calcium hydroxide. Next, molarity of calcium hydroxide is 0.025 molar given. Next, volume of H3PO4 is 100 ml. Next, molarity of H3PO4 is equal to 10 power of minus 4 molar. So these are the known values only for H3PO4 volume and H3PO4 concentration. Calcium hydroxide concentration known, we have to calculate volume. So here molarity relation only given, Generally, we know that the condition for normality into volume of acid is equal to normality into volume of base. So now by using this, already we know that one relation between the molarity and normality. So convert into normality. Na? Normality is equal to molarity into n factor. So by using this formula you will get here molarity of calcium hydroxide known value, that is 0.025 molar into n factor of now we are calculating normality of calcium hydroxide. So here we can write calcium hydroxide is, it dissociate to form calcium plus 2 plus 2 moles of OH minus ions. Here number of OH minus ions are 2, so n factor equal to 2. So we can multiply with here 2. You will get here normality of calcium hydroxide. Multiply this one, you will get 0.05 normal. Then next coming to the H3PO4. Here normality of H3PO4 equal to concentration is 10 power of minus 4 molar into what is the n factor? Now H3PO4 after dissociation it gives 3 moles of H plus ions plus PO4 minus 3. For acids it depends on the number of H plus ions only. How many H plus ions are releases here? 3. So n factor equal to 3. Multiplied here 3. We will get here 3 into 10 power of minus 4 normal. So normality we got, substitute the values into the given formula. So for acid n 0.05 into volume is equal to, we have to calculate, which is equal to normality of the, so first we took here base only, my H3PO calcium hydroxide, next H3PO4 is the acid. So acid concentration is 3 into 10 power of minus 4 into, what is the volume of this one? 100 ml. This is the 100 ml. So finally we will get volume is equal to, so 3 into 10 power of minus 4, it is, we can write 10 power 2 by 5 into 10 power minus 2. So 10 power minus 2 means if 10 power minus 2 going to up, so 10 power 2, this all cancel with each other. Volume is equal to, we will get here 3 by 5, which is equal to 0.6 ml. So volume we found here, that is 0.6 ml. So this is the answer, 0.6 ml. So we can easily identify by using this method by the conversion of normality and molarity relation. Then next another problem we will discuss. Okay, next here 100 ml of 2 molar HCl solution completely neutralizes 10 gram of a metal carbonate. Then equivalent weight of the metal is. In this question he is asking equivalent weight of the metal only, but here metal carbonate given, it is not exactly basic solution only, but he is not mentioned any metal here. So for this kind of questions, how to solve this? Okay, now listen. Now here acid given, here volume given, concentration given. Here metal carbonate, what is the formula? For given HCl molecule, the n factor equal to 1 only. So we can write here normality and molarity both equal only. So normality is equal to, now I am taking 2 normal of HCl, and volume is equal to 100 ml. What about the metal carbonate weight given? So weight of metal carbonate, which is equal to 10 grams. So what is the relation here? Normality, volume and weight. So we have one relation, that is normality into volume by 1000 of it is acid, which is equal to weight by gram equivalent weight of base. That base is here nothing but metal carbonate. So next here we can write the normality and volume in substitute here. Normality 2 into volume 100 by 1000 of acid, that is HCl molecule, which is equal to weight 10 grams given. What about the gram equivalent weight of metal carbonate? So gram equivalent weight of metal carbonate means we can write here one formula: gram molecular weight by n factor is equal to gram equivalent weight. So here instead of that equivalent weight we can write gram molecular weight by n factor. So here what is the n factor value here? He mentioned metal carbonate. So if you want to write that metal carbonate, metal plus carbonate, CO3 minus 2. So here CO3 minus 2 means metal charge plus 2 na? So we can write here n factor is equal to 2. So we can substitute that value in this equation. We will get here 2 0 0 cancelled. 2 by 10 means so if you write here 2 also, it is into 2. So 2 by 10, which is equal to 10 into 2 by gram molecular weight. So in this case 2 cancelled. Now gram molecular weight, which is equal to, if it is coming to left side, multiplied, 10 is going to right side, multiplied with numerator 10, 100. Okay, we are getting here 100 only. So in this process, gram molecular weight of which one we got? Base Ma metal carbonate. So in this metal carbonate 100 grams means it is a molecular weight. What about the total? Metal plus carbonate. Carbonate already known. So we can write molecular weight of carbonate is 1 carbon 12, 1 oxygen 16 into how many? 3. 16 3s are 48. 48 plus 12, 60 grams. Okay, ma? This is the 60 gram. 60 grams molecular weight of only carbonate only. So we can write by using this metal carbonate is equal to atomic weight of metal plus molecular weight of CO3 minus 2. So metal carbonate weight we got 100. So substitute here, it is 100. Here atomic weight of metal only, now we are calculating, it is X, plus molecular weight of CO3 minus 2, 60. So by using that, X is equal to, we can write 100 minus 60. Now 100 minus 60 only. You will get here 40 grams is the atomic weight of metal. So atomic weight of metal is equal to 40 gram. Then finally what he is asking? Equivalent weight of the metal. Question. Equivalent weight of the only metal. So equivalent weight means what is the formula now? Equivalent weight of metal is equal to atomic weight of metal by n factor. So what is the n factor of metal? Already we wrote metal plus 2. So n factor equal to 2 we can take. So take by 2. Take by 2. So equivalent weight of metal is equal to atomic weight 40 by 2. You will get 20 grams is the equivalent weight of metal. So by using this we can calculate equivalent weights also, number of gram equivalents, normality, volume. So this is the equivalent weight of the metal final answer. So 20 grams only is the answer. This is the answer. Thank you.